Okay, I don't think I have to spend too many words to convince you that astronomy and cosmology are very much indebted to space technology, starting with what I consider the first real space astronomical observatory, International Ultraviolet Explorer, and then going to the HST and then JSWST, and all the cohort of astronomical instruments that have been put in space. Having access to the entire electromagnetic spectrum has been instrumental to have currently a much clearer view of the universe evolution. So it is quite ironical that today the same space technology and the so-called new space economy are threatening both astronomy and cosmology. So what happened and what has changed? So until recently, space was the domain of national and international space agencies. And they, using taxpayers' resources, they had as a goal the scientific and technological advancement and space exploration. Today, space is becoming the domain of private companies that have profit as their unique objective. Of course, they are providing services to the society, but I don't think that Elon Musk is deploying this large constellation for philanthropic reasons. So that is a major change in the utilization of space, and the very nature of the threat call for innovative mitigating measures. And the large satellite constellation that I will be talking about in a moment are just the first example of the possible threats of this new space economy to science. So the root of the problem is an exponential increase in the space activity and the population of the low Earth orbit. If you look at that in 2019, there were about a bit more than 2,000 satellites in low Earth orbit. And last year, they increased by 3 times in 4 years. And if you look at the active and inactive satellite, currently they are around 10,000, not to talk about the space junk. But what is really disturbing is that this is becoming a real rush to the constellation. And so if you look at the planet constellation, you have this very incredible number going up to hundreds of thousands. Now, not all of them will be deployed and launched, but we expect that certainly several tenths of thousands of satellites will be orbiting in the low Earth orbit in the near future. And so I don't have to tell you what is the reason why they are interfering. They are, for most of the time, for most of the night, illuminated by the sun, and so they are reflecting the sunlight, and just the huge number of satellites is impacting the optical and infrared observation. And of course, they are there. They are there to provide connectivity to internet, so they are emitting microwave radiation toward the Earth. And on the right, you see an old image of the microwave sky, where you see clearly the stream of geosynchronous satellites, which are fixed there and located, so the disturbance is very well confined. You can imagine that when the entire sky will be populated by the satellite, the sky will become very bright in microwave, so interfering strongly with the observation. Certainly, observation from the ground of the cosmic background will be almost impossible and have to be done from space. You to see here, the problem is that you cannot really go around with processing of these images because of the crosstalk in the detector. So if the recommendation that we are making about the limit of the magnitude of this satellite is below 7 magnitude, then there's still a possibility of doing removal of the trail. Of course, you are always losing something in the observation, but this will be still tractable. But as soon as you have satellite like the current population of Starlink, then it becomes already difficult. And if you have something much brighter like Blue Walker 3, then the interference is really destroying all possibility of making recovery from the observation. In radio, the situation is even worse because, first of all, although the satellites are not emitting in the bands that are protected for radio astronomy, they are very close, adjacent, and so you can imagine that you have spillover from the satellite. And then you have also this unintended electromagnetic radiation, which is emitted not intentionally, but is still there. And recent observation with low farm show that this radiation is indeed visible and disturbing the observation. So this is the type of interference that we are experiencing and projecting in the future, becoming very much affecting the all type of observation. So the IAU has its main mission to promote and safeguard astronomy in all its aspects. So we couldn't have remained inert in front of this new situation. And so the executive committee, when we started discussing this around 2020, it was decided to follow two lines of attack. One is to act at the level of the UN Committee for the Peaceful Use of Outer Space, where the IAU is sitting as a permanent observer, and raise the attention about the problem and try to find some regulation that would mitigate the impact of the constellation. We know by experience that obtaining some type of regulation at that level is very difficult and very lengthy process. And so we couldn't just use only that line. So we take another more direct, pragmatic action, creating a center, which is the Center for the Protection of Dark and Quiet Skies from the Interference, which started in 2022 and is directly, as I will show you in a moment, discussing with the companies to find mitigating measures that can be considered an acceptable compromise between the deployment and the use of the constellation and the observation. Now, what has been immediately decided by the IAU that we will not go along taking a legal action against the company, because that I think would be unreasonable. I'm mentioning this because there are still some astronomical minorities that want to go along that line, but we don't think that will go anywhere. In fact, accessing, these constellations are deployed to make internet connectivity for all. And that is one of the sustainable development goals. And so it's proven to give access to internet to remote areas. You can connect even from the middle of the ocean. And we have seen that this is indeed a very useful progress in connectivity. So we do not want to stop that. However, the interference on astronomy and the visibility of the night sky. One has to consider that is not only the science affected, but is also the deployment of this constellation is affecting the visibility of the night sky, because a fraction of these satellites are visible by the naked eye. And the situation will, of course, become worse in the future when all the constellation will be deployed. So the IAU decided to create this center, which is a coordinating center. It doesn't have much staff, but has two locations, physical location. One is at Noir Lab in Tucson, and the other one is in Manchester at the SKO Observatory. And then we have 4 areas of activities, which we called hubs. The SAT hub is devoted to monitor the luminosity of the satellite where they are deployed. And so we are organizing observing campaigns, which are very useful for us to understand the real impact of the constellation on astronomy, but they are also useful, and they are requested actually by the company to test their mitigating measure that they start implementing. They are also active in this area on the determination of the exact position, or the very precise position of the satellite, which, as I will discuss in a moment, is probably the most effective mitigating measure that we can adopt. There is a second group which is considering all legislation or regulation and policy at both the national and international level that may be used to promote our action at the UN Committee for the Peaceful Use of Outer Space. And they already produced an important position paper about the situation in terms of legislation and regulations. Then we have an industry and technology hub, which is the one that are discussing directly with the space company, space industry, to find possible mitigating measures both in terms of the structure of the satellite and also for their operation. One thing that is quite clear is that the luminosity is very much dependent on the attitude of the satellite and the attitude of the solar panel with respect to the observer and the sun. And so there are measures that can be mitigating this flaring that sometimes we observe from the satellite. And then one important area of activity is the so-called community engagement. There we want to, on one side, inform the society, but in particular minorities, about what is happening to the sky and get their reaction. In particular, some indigenous population that have still a very close connection to the sky, they will be more affected than people living in Western cities where the stars are not visible anymore. But they are feeling very much about their connection to nature. And so we want to get their reaction to the situation and highlight that to the level of the society at large. Now, the question is mitigation possible with this situation? Well, first of all, the satellite can be made less reflective. And if we achieve that, then the pristine vision of the night sky is preserved, so the cultural heritage of the visibility of the night sky is preserved. And as I showed before, the astronomical detectors will not be saturated or damaged by the satellite rays, so that can be removed by post-processing to some extent. That, of course, is not the final solution because you will always lose some data. And in particular, the most tricky thing is for spectroscopic observation where you don't have direct information about the possible interference of a trail in your spectrum, that in that case will be contaminated. If you don't know if the satellite has passed across the slit of your spectrograph, then you would not know that it has been contaminated. So the best solution to avoid this interference is to have the possibility of knowing exactly the position of all the satellites at any time. And so you can interrupt the observation, or in a post-processing, you would know that if the satellite was crossing your field of view or your spectrograph slit or either. Now, in principle, this should be possible. The data, the orbital data elements of the satellite, of all the satellites, are public. However, they are not accurate enough to make this prediction effective. And the reason is that because of the large population of satellites, they have an automatic system to avoid the risk of collision with each other. So they are changing their orbit very frequently and in an autonomous way. And so you need to have a real-time knowledge about the position. So there are two lines that we are exploring in the CPS. One is to obtain the precise prediction by mathematical models, or to have an auxiliary telescope or facility that will detect the incoming trail before it enters into the field of view of your scientific observation. Both of these solutions become a solution which is available to everybody, require an important financial investment in order to go from a prototype solution to something that is offered to the community. So we are almost at the level now, reaching the level where we are ready to go for this if we have the financial resources. So there will be certainly a campaign for fundraising on this, and if we don't have that, it would be very difficult to provide this service. In the radio domain, the situation is even more complicated because these satellites are there to emit in radio wave and in microwave. So either you switch them off or the interference is there. So what we are discussing currently with the companies is that we want to define some radio quiet zone around the major radio astronomical facilities, and the company then will have to agree to deviate the beam of their emission when they are over this major, this radio quiet zone. Fortunately, most of the very large astronomical facility are already built in remote areas where there is almost no population. And so the company, in particular Starlink, is amenable to do this, to deviate the radio, because there is no financial impact. I mean, they're not losing any money for that. Of course, all this part of the radio interference is also the domain of the International Telecommunication Union. And indeed, in the last big conference that they have in Dubai, this matter has been discussed. And now they have created a working group on this particular aspect that will start studying possible measures and legislation for the utilization of the radio bands. And so we will have to hope to see something that is said. It's quite clear that the situation that is happening with the deployment of this large constellation took almost everybody by surprise from the consequences. And of course, also you can imagine that they're not only the impact on astronomy and science, but there's also an impact on the operation of the general operation. I mean, the risk of collision is increased. Traffic management is something that the space agency are being looking at. And then there is a very big problem that we are not investigating because we don't have the experience to do that. But I mean, in order to maintain this large satellite constellation, you have to refill the number of satellites continuously. So the number of launches and re-entry of the satellite is increasing dramatically. And the effect of that on the upper atmosphere is not yet been studied completely. So that is another threat, not to astronomy, but in general to climate change and the life on Earth. So that is an area that we are not directly involved, but we know that is very important to investigate. So, as I said, the mitigation is possible, but we need a strong collaboration with the satellite industry and private companies. We are trying to invest to see what is the best practices that have been found useful. And the important thing is to share this knowledge to the new companies that are now planning the deployment of other constellations. Because if this knowledge is shared with them at the early stage of their design, then it is more probable that they can implement them without affecting their goal. So we are working along those lines, and the center is obtaining some satisfactory result in the conversation with the companies. However, the situation is clearly in fast evolution, and we have to be careful about the possible future of the constellation. And in order to remain effective, the best practices need to be acknowledged and supported by government. So that is the other line of attack, which is to talk at the Committee for the Peaceful Use of Outer Space. And that is what we have been doing since 2020, when we started presenting a technical presentation about the simulation of the impact. And that was mainly for raising the attention. Then in the following year, we presented the so-called conference room paper together with Chile, Ethiopia, Jordan, Slovakia, Spain, and the other astronomical observer. And that was already giving some positive reaction. And then we continue pushing for having a dedicated agenda item, which means that we have dedicated time in the meeting. I need to say that this STC is the Scientific and Technical Subcommittee of the committee, and it's there that these type of problems are discussed. STC is meeting once per year in February, and so the proceeding there and progressing there is very slow. And we insisted to have a dedicated space in the meeting where we can discuss specifically the problem of the dark and quiet sky. We succeeded to have it in 2022, and then we continued to propose that for the future planning. And it was becoming then very difficult. The discussion became very mixed up with our purpose is the scientific protection, the science protection of science. But it's quite clear that under the current geopolitical situation, this constellation has created a problem to some delegation because the use of this constellation is considered an interference with some of the action of some delegation that you can imagine which of them. But fortunately, last February, after a long battle, we achieved the goal of having this agenda item approved for 5 years, which is great. And we have to struggle with the name of the title of this agenda item, which is finally this one: Dark and Quiet Sky, Astronomy and Large Constellation, Discussion on Emerging Issues and Challenges. It was not easy to reach consensus of that. And I must say that the entire meeting of this Scientific and Technical Subcommittee last February was almost dedicated to discussing dark and quiet sky, not because of the interest of delegation on protection of astronomy, I must say, but because of the interference of the, particularly SpaceX on Starlink, I mean, and on other matters. You can imagine what they are. So this is the situation. And the good point is that because of the pressure that we made, we have created now a so-called group of friends, which means a number of delegations are declared that they want to work with us to study the impact of the satellite constellation and try to work together to find solution, which is very important because then the national control of the space company will be amenable to the fact that they have to be careful about the impact that it may have on astronomy. And as you can see, we have a large number of delegations that agree to be part of this group of friends, there are some, I mean, all this has been pushed very much by Chile and Spain. And so we hope that this is giving us support at the international level. Now, my conclusions. I think that we have to try to turn this problem into an advantage. It's quite clear that astronomy has never enjoyed the current visibility at the UN level, international level. So we should use the favorable situation to convince policymakers and the society at large that, first of all, astronomy is absolutely instrumental for progressing in the understanding of reality. And that is already being accepted in sense at the level of COP. So this is a very important goal, but then we can use that further. And we have to propose that cosmology and cosmologia, here I'm using the definition that Richard Ellis is proposing, that we are to move from the scientific cosmology to a more global understanding of the reality, which is called cosmologia. And that can help promoting peace and tolerance, because not only we are all live under the same sky, but we are the universe. We are the sky and its consciousness. And so in order to achieve that, in my opinion, we should critically review our outreach goals, and we will talking this afternoon about that. And since we are here in the Vatican, I think that we have to follow the seminal thought of Georges Lemaitre and Pierre de Chardin.